Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues, and please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solutions of three questions, question numbers 4, 5, 6, that have appeared in the JEE Main exam of January 2025 session. And these three questions are from the section Sets, Relations and Functions. These three questions are from sets and relations. These three questions are related to sets and relations. Right. This is the fourth question. This question has appeared in the JEE Main held on 29th January 2025 in the morning shift. The question is related to relations. The given question is: define a relation R on the interval, it is a semi-closed interval 0 to pi by 2, closed at 0 and by x related to y by the relation R if and only if secant square x minus tan square y is equal to 1. Then R is, we are given four options. Option 1, an equivalence relation. Option 2, reflexive but neither symmetric nor transitive. Option 3, both reflexive and symmetric but not transitive. Option 4, both reflexive and transitive but not symmetric. Let us now discuss the solution of the problem in detail. We have R, a relation on the semi-closed interval 0 to pi by 2, closed at 0 and defined by x is related to y by the relation R if and only if secant square x minus tan square y is equal to 1. Let us now check one by one for reflexivity, symmetry and transitivity of the relation R. First, we take y is equal to x. So that means we are going to check reflexivity. When y is equal to R, then x related to x if and only if secant square x minus tan square x is equal to 1. Wherever there is y, substitute x. X related to x by the relation R if and only if secant square x minus tan square y is equal to x, tan square x is equal to 1. Yes, this is an identity. This is true for all x belongs to the semi-closed interval 0 to pi by 2. That means x is related to x for all x belongs to the interval. Thus, the relation R is reflexive. Right. Now, let's go to the next slide for the discussion of the remaining two properties of the relation R. Second, x related to y. Our idea is x related to y implies y related to x. Is it so? If it is so, then it is symmetric. X related to y implies, by definition, secant square x minus tan square y is equal to 1 for all x belongs to the semi-closed interval 0 to pi by 2. This implies secant square x minus tan square y is equal to 1. That will imply, for secant square x we have written 1 plus tan square x minus, for tan square x we have written secant square y minus 1 in brackets. Right. Now simplifying, 1 cancels and you get a tan square x minus secant square y is equal to minus 1. No, there is 1 is not cancelling. Yeah. Minus of minus 1 is plus 1. 1 plus 1 is 2. That 2, when sent to the right hand side, 1 minus 2, that becomes minus 1. I'm sorry. Right. So now multiply throughout by minus 1. Then you'll get secant square y minus tan square x is equal to 1. It means y is related to x by the relation R. So x related to y implies y related to x. Then it will tell you your relation R is symmetric. Right. We go to the third property for the transitivity. X related to y and y related to z. If we can prove x related to z, then it is transitive. So x related to y means secant square x minus tan square y is equal to 1. Y related to z means secant square x minus tan square z is equal to 1. Right. So we will add these two things. So secant square x minus tan square y plus secant square y minus tan square z is equal to 2 on adding. For this secant square y, which is written in red, write 1 plus tan square y. Right. Tan square y cancels. And on the right hand side we have 2. Send this 1 to the other side, you will get 2 minus 1 is equal to 1. Then after simplification you will get a secant square x minus tan square z is equal to 1. This implies x related to z. So x related to z, whenever x related to y and y related to z, it means that the relation is transitive. Thus, our relation R is reflexive, symmetric and transitive, and any relation satisfying all these three properties is called an equivalence relation. Therefore, the relation R is an equivalence relation. Right. Let's look at our options. Our answer that it is an equivalence relation appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of this problem, and it is a very simple, straightforward question. Right. Let's move to the fifth question. This question has appeared in JEE Main 28th January 2025 exam in the morning shift. It's on relations. The given question is the relation R is the set of all ordered pairs x comma y, where x, y belongs to the set of integers z, and x plus y is even. And we are given four options. Option 1, reflexive and transitive but not symmetric. Option 2, reflexive and symmetric but not transitive. Option 3, symmetric and transitive but not reflexive. Option 4, an equivalence relation. Right. And it is a very, very easy question. And very rarely such questions occur in the JEE Main examination. Anyway, you are lucky to have a very simple question now. Now let's now discuss the solution of the problem in detail. We are given the relation R is the set of all ordered pairs x comma y, where x and y belongs to the set of integers z, and x plus y is even. Let us check the properties. 1. For any x belongs to z, for any integer x, x plus x is 2x is even. Whatever may be the x, but 2x will be even. That means the ordered pair x comma y belongs to R for all x belongs to z, thus R is reflexive. Second property. X comma y belongs to R implies x, y are integers and x plus y is even. When x plus y is even, y plus x is also even. So that will imply y comma x, the ordered pair, also belongs to R. So y comma x belongs to R whenever x comma y belongs to R. Therefore, R is symmetric. Option 3. X comma y belongs to ordered pair x comma y belongs to R and y comma z belongs to R implies x, y, z are integers and x plus y is even because x comma y ordered pair belongs to R. And y plus z is even. This implies x plus y is even, means 2 times some integer m, and y plus z is even means 2 times n for some integer n. Adding, you will get x plus y plus z, x plus 2y plus z is equal to 2 times m plus n. That will imply x plus z is equal to 2 times in brackets m plus n plus y, and m is an integer, n is an integer, y is an integer, m plus n plus y is an integer. 2 times of that is an even integer. So this implies x comma z belongs to R. So thus R is transitive. So R satisfies all the 3 properties: reflexivity, symmetric, and transitivity. Therefore, R is an equivalence relation. So let's look at our options. Options are given here, and the answer to this question is option 4. Right. That is the detailed discussion of the solution of this problem, and it is one of the most simplest questions that I have seen on relations in the JEE main examinations. Anyway, you got a simple question. Be happy about it. Move to the next question, question number 6. This question has appeared in JEE main examination held on 24th January 2025 in the second shift, and it is related to the sets, and it is precisely to find the number of elements in the union of 2 sets A and B. That is, n of A union B you are required to find, and it's a good question. Let A is equal to the set of all x belongs to the open interval 0 to pi minus the singleton set consisting of pi by 2, such that log of mod sin x to the base 2 by pi plus log of mod cos x to the base 2 by pi is equal to 2, and B is the set of all x greater than or equal to 0 such that root x into, in brackets, root x minus 4 minus 3 times modulus of root x minus 2 mod is closed plus 6 is equal to 0. Then n of A union B is equal to. Right. It's a good question. Now we are given 4 options. Right. Now let's now discuss the solution of the problem in detail. We first take A. So A is here. A is here. So A is set of all x belongs to the open interval 0 to pi other than pi by 2, and log of mod sin x to the base 2 pi plus log of mod cos x to the base 2 pi 2 by pi is equal to 2. First take this equation and solve for x. So this equation we have taken, and log of A plus log of B is equal to log of AB. That will imply log of mod of sin x multiplied by cos x to the base 2 by pi is equal to 2. Take over the log, you will get mod of sin x cos x, we have written 1 by 2 into sin 2x mod of is equal to 2 by pi to the power of 2, that is 2 by pi whole square. That is mod sin 2x is equal to 2 times 4 by pi square, that is 8 by pi square. And when you see what is this value 8 by pi square, it is approximately equal to 0.81. Yeah, this is worth noting. This is required. And this is less than 1 also, you don't know. And therefore A is the set of all x belongs to the open interval 0 to pi other than pi by 2 is such that mod sin 2x is equal to 8 by pi square. Right. And the easiest way is to draw mod sin 2x graph. This is the red one, is the mod sin 2x graph between 0 to pi. Pi by 2 is not included. Right. And as I have told you that 8 by pi square is approximately equal to 0.81, which is less than 1. Now draw a straight line parallel to x-axis, and the straight line is y is equal to 8 by pi square line you draw. It's less than 1, therefore it intersects. It intersects. Right. It intersects in how many points? 4 points. So, therefore, the number of solutions in 0 to pi other than pi by 2 is 4. Therefore, n of a is 4. This is the easiest way of getting the answer n of a is equal to 4. You have to note down 8 by pi square is approximately equal to 0.81, which is less than 1. And you have to note down mod sine to x graph, modulus graph is this one only. Mod sine graph is this. And pi by 2 is not included. Agreed. The line y is equal to 8 by pi square parallel to x-axis. Because 8 by pi square is less than 1, it intersects in 4 points. 4 points in the interval 0 to pi other than pi by 2. Therefore, the values of x corresponding to these 4 points are the elements of A. Right. N of A is equal to 4. Right. And we move on to B. B is an algebraic equation. X, the set of all x greater than or equal to 0, such that root x into, in brackets, root x minus 4 minus 3 into bracket modulus of root x minus 2 plus 6 is equal to 0. Okay. We first solve this equation. Right. For this, put y is equal to root x in this. So, this will imply y into y minus 4 minus 3 times modulus of y minus 2 plus 6 is equal to 0. Simplifying, y square minus 4y minus 3 times modulus of y minus 2 plus 6 is equal to 0. So, because y minus 2 is under the mod, we have to deal with the two cases. One case is y minus 2 greater than or equal to 0. The second case is y minus 2 is negative. The first case, let y greater than 2. That means y minus 2 greater than or equal to 0. Then modulus of y minus 2 is y minus 2 only. Simply substitute here and solve. So, y square minus 4y plus 3 times mod y minus 2 is y minus 2 plus 6. Simplify, you will get y square minus 7y plus 12 is equal to 0. And the factorization is very easy. Y minus 3 into y minus 4 is equal to 0. That implies y is equal to 3, 4. That is root x is equal to 3, 4. Squaring, you will get x is equal to 9, 16. Now you note down here itself 9 and 16, x is equal to 9 and 16 lie beyond this interval, because this interval is 0 to pi. X belongs to 0 to pi other than pi by 2. When you take x is equal to 9, x is 0 to pi means 3.14, but it is 9. It lies outside. 16 also lies outside. That is the observation you make now. Case 2, when y less than 2, when y minus 2 less than 0, then y less than 2, then modulus of y minus 2 is 2 minus y. So, wherever there is modulus of y minus 2, you write 2 minus y and simplify. Right. 3 into y minus 2. In that place, 3 into modulus of y minus 2. In that place, we have written 3 into 2 minus y. Here, it should be a modulus. Right. So, when you simplify, you will get y square minus y is equal to 0. That implies y into y minus 1 is equal to 0. Y is 0 and 1. That is root x is equal to 0, 1. Squaring x is equal to 0, 1. And you also note down that 0 doesn't belong to A, because it is the open interval 0 to pi where 0 is not included. So, x is equal to 0 is not there in A. It only should talk about 1, whether it is in A or not. So, what are you trying to say? What are 9 and 16 and 0 to 1? That is B. B is the set consisting of 0, 1, 9, 16. Those are the solutions. So n of B is 4. And in this we have already noticed 0, 9, 16 doesn't belong to A. Only the question is whether it belongs to A or not. That means what are you trying to say? How many elements are there common to A and B? That we discuss in the next slide. Right. We have A, we have B. Claim. Our claim is A intersection B is empty. That means there is no element common between A and B. So clearly 0, 9, 16 doesn't belong to A because 0 is not in this interval, union of these two intervals 0 to pi other than pi by 2. 0 is not there by definition. And you also note down 9 is greater than pi, 16 is greater than pi. So 9 and 16 also doesn't belong to A because in this interval they lie beyond 0 to pi. So it's only the question is whether 1 belongs to A or not. What are we trying to say is what are the common elements between A and B? Assume that 1 belongs to A. I thought this is the only possible argument that we can put forth here. This implies 1 belongs to A means it should satisfy mod of sine 2 into 1 is 8 by pi square. Modulus of sine 2 is sine 2 only. Sine 2 is 8 by pi square. 8 by pi square. Now, sine 2 is measured in radians. Sine 2 is 0.91. 8 by pi square we have already seen it is approximately equal to 0.81. If you say 1 belongs to A, sine 2 must be equal to 8 by pi square. It means 0.91 is equal to 0.81, a contradiction. Therefore, 1 doesn't belong to A. So there is no element common between A and B. A intersection B is empty. A and B are disjoint. Then n of A union B is equal to n of A plus n of B. Because they are disjoint, it's only n of A plus n of B. That is 4 plus 4, that is 8. Look at our options. Our answer 8 appears against option 3. The answer to this question is option 3. So that is the detailed discussion of this question, and this question is a good question. Agreed. Right. I am sure that you have understood these 3 questions. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Let's hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.